All right, let's get started. Thank you very much for being here. Very happy to be visiting Philly for the first time ever. First time at Philly Emerging Tech. Fantastic content, amazing content. I've mostly been going to Ruby on Rails, and that sort of conference. So I'm very excited to be here. What I hope to talk about today is this idea of general purpose, and especially as it relates to languages. To start that off, I have a question for you all. What do you think the next 10 million programs that are written will look like? Next 10 million programs. This is actually a much bigger question, has a bunch of questions inside of it. So, who's going to run those programs? Who's going to write them? How are we going to write them? Who will use them? Where will they run? Does this question keep you up at night? Keeps me up at night, and this is why. This is the context that we are operating in. It's the digital revolution. Basically the idea that anything, and I mean anything, that can be created, delivered, or consumed digitally will be. Not maybe, not if it's cheap enough, which we'll get into, but it actually will be. And it's in this context that we have this existential struggle, right? It is a question of, do we exist as a company or not? If we're creating value for our customers, then we'll continue to exist. And if we're not, we won't. More specifically, are we creating value through the software that we write? Because after all, this is a conference about software, right? So this is why that question keeps me up at night. And I would argue that this is why that question should keep you up at night as well. The problem is that as we're trying to create value for our customers, we are too slow, we make too many errors, and we cost too much. And I don't think there's any avoiding that. I can pull many examples out, but I think we can just work through some of these and recognize that this is the state of affairs today. So in the very opening of the conference, it was mentioned that the speaker said her father worked at NASA, and this idea of we have more computing power, more memory, most of us in our pockets, than NASA used to put people on the moon. But if we have 1,000 times more memory in a tiny device, probably more than a few thousand times smaller, are we creating 1,000 times more value? Is a billion-dollar company in 1960 a multi-trillion-dollar company today? It's really not, right? And it doesn't seem like we actually ask that question a lot. So this idea of being too costly is significant. Failing too often. Don't have to reach too far back in memory to look at somewhere where we basically did all of these. It was too slow, it cost too much, and it failed initially. Healthcare.gov. I mean, there are tons and tons of things that we can point to where we fail. There's a new post that I saw recently on Medium where they were looking at a physician-assisted prescription program that ended up giving a young man like 38 times the dosage of some medicine. Made him very ill. That's very recent, right? So historically there are a lot of failures that people point to, but it's continuing, right? So we're too slow, we cost too much, and we fail too much. And this goes right to the core of that problem of creating value for our customers. Now, the typical response to this, and not meaning any disrespect to any of the speakers here, but the typical response to this, the thing that we keep hearing is either we need, different programming languages, so let's go do functional programming, right? Or we need different frameworks, right? So let's abstract stuff and make it so we can more quickly create value. Or How about this? How about we need better methodologies, right? So have you adopted Agile yet? Are you sure? It's a big question, right? So Dr. Dobbs' journal, you may have heard of it, it looked at, and again, these should all be in air quotes, Agile and traditional, but they basically, in two different studies, they looked at companies that reported using Agile versus traditional, which probably means something like waterfall, and the success rates of those projects that were claiming to use Agile or traditional. Pretty close. Might be a wash. Which to me is something, so I grew up sort of with Agile. I was doing programming before Agile. And I think that many of the stated goals of Agile are very aligned with what I think we need to do. But at the same time, how do we explain this questionable success? And the frustration that I have with it is that if you talk to someone about Agile, the answer might be, well, you're doing it wrong. Well, that's not actually Agile. Agile is this thing over here. Well, if the answer to here's this thing that should help us not be too slow, not cost too much, and not fail so much is you're doing it wrong, please go back and figure it out and come back and tell us how to do it so we're not doing it wrong, right? Okay. So a little bit about me. I work at a company in Chicago called Innova. We are an online lending company. We operate in the UK, the US, Australia, Canada, Brazil, and China. We have a spectrum of applications that go from a monolithic application to newer service architecture, little detour through a distributed program in there. We do a lot of interesting stuff, and I'm primarily working with them to migrate applications to the project that I work on, which is called Rubinius. And I'll get into that in a second. We are hiring, if you're interested. So Rubinius is an open source project. Over the years, as I've been talking about it, it has evolved from describing it as an implementation of the Ruby programming language, which it is. We run Ruby, we run a lot of Ruby code. We are both compatible with the MRI, or the standard Ruby interpreter's C API. The standard Ruby interpreter is actually written in written in C, and so a lot of people write extensions that just use random C functions. Our architecture is radically different, has a different type of garbage collector, somewhat different VM, JIT, and so people using random C functions in MRI makes it very difficult for us to support their code in Rubinius, but we've worked on that a lot. A lot of the parts of Rubinius, the compiler toolchain, and other tooling, the entire Ruby core library is all written in Ruby. So one of the early goals of Rubinius as a project was to make it possible for typical Ruby developers to experiment with the language by actually seeing the code that they are running in Ruby, being able to interact with it, and also to create a more consistent basis or platform on which to implement stuff, right? So the just-in-time compiler can see your code, it can see the kernel code, it can put them together with inlining. You can debug your program and you can go into the system code and back out into your program, things like this, right? So those are some goals. Over time, I've started describing the project more as a language platform, right? So we have a bytecode virtual machine, a generational garbage collector, just-in-time compiler based on LLVM. And it's a platform that people have targeted with a number of different languages, some of them very simple toy languages and some of them pretty complex. Most recently, how I've started to look at this program is a philosophy more than anything else. And the transformation that I've gone through in working on this project and really questioning how do I create something that empowers people to create programs, and not just to create programs, you know, like my hobby is to create programs, although that's fine, but to create programs that are solving real problems, solving hard problems, solving business problems. So one of the things that Rubinius does not have is a global interpreter lock. So if you know anything about Ruby, you've probably heard that Ruby is terrible at concurrency, and in fact it is. Rubinius is not. We have no global interpreter lock. We can take advantage of all of your cores. And so working on this project and struggling with understanding, why does Ruby work well in this situation but not in this situation? Why does someone become very committed to Ruby and then go on and do something else? If you heard Yehuda Katz's talk on Rust, Yehuda is a longtime member of the Ruby community. We don't see him much anymore. And it's not because he doesn't have great ideas, and it's not because he hasn't worked very hard. He was one of the initial authors of Bundler, which is a pretty fantastic tool to manage dependencies. In my opinion, and Yehuda might have a different answer, but in my opinion, the language and the environment and the community around Ruby couldn't really keep up. At the same time, Yehuda has experience in jQuery and other things as well, but trying to understand why we could not evolve Ruby to be more useful was one of the fundamental things that I struggled with, right? Why do people want to leave it for a different language? So that forms the sort of my background. My background, I've been working on this project for over 8 years. And like I said, my perception of it now, my perspective on it is more of a philosophy of how do we create a system to experiment with languages. And I'll get into why experimentation is important. But that's where I'm coming from. So I want to go back to the digital revolution, because honestly, a lot of companies didn't get this memo. And I don't mean that in a condescending sense. I mean that very seriously, right? So recently, I moved actually from Chicago back to Portland, and had Comcast in Portland before we moved to Chicago, and had Comcast in Chicago, and had Comcast when we moved back to Portland. Fairly limited on my options. It was pretty much Comcast or Comcast or Comcast. So Comcast is a big company, and I don't mean anybody, again, any disrespect. It's a big company. They have two completely different billing systems for the Midwest and the Pacific Coast. So West Coast had one account, got to Chicago, they're like, oh, we have no idea who you are, we have to make a new account for you. So we did. And then when I got back to Portland, they had to do that again. And while I'm on the phone with the customer care representative, one of the things that we were talking about was my rate. I was paying more now. Why am I paying more? And the idea was well, we can give you faster service for the same price that you're paying now if you'll also sign up for our cable. I was like, okay, does that require that I have a different device? It's like, oh, yeah, we have to send you a DVR sort of unit, right? But it's no cost, don't worry about it, it's no cost. And I was like, my internet works fine. Why would I want another device? All the cost that goes into producing that device, shipping it out to people, trying to convince me that I want it, all of that cost, when actually everything that device can do, Comcast already does. It's the same photons going down the fibers and the same electrons coming down to my thing, but you want me to connect a different device. So in a very fundamental sense, I don't think Comcast got this memo. They still think that there's an option about whether they're going to deliver entertainment, information, news, right, all of these things to me over the normal internet or over this special device, right? And it's not just Comcast, right? So we're probably all familiar with what happened to Blockbuster Video, right? And it's very interesting to read in 2008 where the CEO of Blockbuster is like, yeah, I'm not sure Netflix is really a threat to us. Now, you might excuse that perspective because it was 2008. The internet was only about a decade old. But there's a recent article about mid last year in, I think, New Yorker, where wasn't the Blockbuster CEO this time, but it was, I think, a CBS executive that was like, yeah, I don't think Netflix is really a threat to us. People do want to wait around until 7 p.m., on Tuesday to watch that show. Now, Netflix knows this is not true, right? Netflix will release a whole season, and they know that people binge watch that season. Right? They'll watch, on average, 2.5 episodes at one sitting. Now, these are 40-minute to an hour episodes, right? So do you want to wait around until 7 p.m. on Tuesday to see the new, whatever, Game of Thrones or something? No, people don't want to do that. But the executives are making decisions where they think that that model is still viable. So, and again, I'm not just, bagging on people. These are intelligent people who are looking at the things that they have to deal with and trying to make good decisions. You have to assume that, right? But if companies this big are making these choices, are we possibly making similar things, right? So this is the question that I have. This is why it's so important to me that we understand what this digital revolution is about. But the digital revolution by itself, like what's causing it, right? It's not a primary thing, right? It's more of a consequence. It's something that we observe going around on. And at the core, this is what's going on. Some of you have heard it as described as Moore's Law, right? The doubling of the number of transistors on a chip every about 18 months or something like that. But there's a more basic thing going on. There's this universal thing, especially with living beings, right, that we process information. The processing of information, the sharing of information and knowledge, right, results in the cost of things going down, and it's an exponential curve. There's a couple of inflection points that I've put on this curve because there are very interesting things that happen with this cost curve. Towards the left, where cost is very high, it looks almost like a cliff, right? There's a bit of an intermediate point, and then it really levels out, and it looks like it's just kind of flat. There's a very, very interesting author. He's actually he's written a couple books. He's the author of the Zero MQ. Heard of that, Zero MQ library? I can't pronounce his last name, sorry. But this is what he writes in this book, Culture and Empire. Cost gravity takes emperor's toys and turns them into commoners' tools, and as it does this, it drives profound social, economic, and political change. This is the context that we're operating in now. So taking a look again at this cost gravity graph, I've labeled what I think, I'm making this up, by the way. A lot of this is actually in Peter's book, but these are the things that are really important to me as it comes to software, right? So I've labeled what I consider the sort of inflection points, right? So one of the points that he makes is that we do not have a good intuition for what an exponential curve looks like. So when we see it, we tend to assume it's something else. It's this cliff or it's kind of flat. But there are tipping points, there are inflection points where things completely change. And what I think is very interesting is that I'm looking at technology, I observe this thing where technology goes from impossible, right? The cost would be astronomical, there's no way we could do it, through this place where it's custom. IBM will build you a custom mainframe, right? And from there, it transitions at some point when the cost drops enough to general purpose. You can buy a general purpose computer. And then it goes into this space where it's specialized, where the cost has gone so low that you can make precisely the thing you want. It's no longer general purpose. It's not even, it's not a custom thing. You've taken all the information and you've made a specialized thing, right? It's very specific to a specific task. And what I think is really interesting about this, if you consider this for a second, how many people are adopting the cloud? A lot of people. My question would be is where on this curve do you think the cloud exists as we sort of understand it right now? AWS, what's that? So existence proof would, it exists, therefore it's possible. So no, it's not impossible. I think it's in the general purpose, which means that if we're banking on the cloud, how much time do we have before we enter the specialized space? Now, we might be seeing this a little bit right now when people talk about hybrid cloud or private cloud, but I'm not convinced. I think how we're seeing it is that that whole general purpose thing just continues right out and there's not specialized. And so we're saying, oh, cost structure, whatever, we need to adopt the cloud. And so we're like a stampeding herd towards adopting the cloud. There's a great graph, I should have put it up here, where it's basically like cloud adoption, enterprise IT cloud adoption, right, lagging about 4 to 5 years, and this oh shit moment where it kind of catches up with everybody else, right? I feel like that's where we're at, and if that's where we're at, what are the assumptions that we're making? So talking about those assumptions for a second. Anybody ever been part of a big rewrite? A few of us. What I think is fascinating is that when you get to the point of the big rewrite, there's all this, oh my God, what were they thinking? And like, oh, this is crazy, and all this sort of stuff. But let's go back. Like, either we have to assume that a bunch of business people really understand nothing, and it's like, it was a political decision, the vendor took the guy out for dinner, all these sort of things. Right? You have to make all these assumptions about counter-rational behavior, or I think a much simpler explanation is that we go back and we look at where in time this project originated and what the cost gravity graph looked like at that point. And then the project was created, and its cost line tends to follow this other thing. And we can talk about why that is, right? So it tends to go out there. That red gap that starts getting bigger and bigger and bigger with the, oh my God, what's going on? Until finally, someone's like, we got to rewrite this stuff. And then you do that. But I think what we tend to do at that point, right? We don't build in responsiveness to that cost gravity function. Instead, at that point where we do the big rewrite, we repeat history. And then that goes out for a while. So this is basically why I think that the cost gravity is such a fundamental concept that we really have to get a handle on. So there's an author, sorry again, I have no idea how to pronounce his last name. If anybody does, please tell me. Shirai, I think, something like that, Michael Shirai. He's written a book, What Do You Want Your Customers to Become? And his fundamental point is that the question we should be asking is not how do we delight or impress or whatever our customers, which he says is very narrow-minded and short-sighted. Instead, he's saying we should be asking, what do you want your customers to become? He says, when you accept the tangible reality that innovation changes who you become, you begin to acquire the ability to innovatively empathize with your customers. And he uses a great example, the mobile phone. And in his book, he says, you might respond to the question, how has the mobile phone changed you? With, well, it really hasn't changed me. I'm basically the same person. Have you ever used Siri? So one of the points he makes is that someone who talks to their phone or talks to Siri on their phone multiple times a day is very different than a person the you who did not do that, right? So I think it's inescapable that what we're doing with technology is transformative, right? We innovate to provide value to our customers. Our customers are transformed. And if we want to take advantage of this, if we want to build in a virtuous cycle here, I think we need to look at something like this. So again, innovation, our customers engage with that, there's transformation. If we want to understand the innovation and the transformation, we need to be collaborating with our customers, and that involves experimentation. And the difficult thing for me to express here is that this is not just, sort of one way. I've drawn this like it's a cycle, but there's a lot of cross-interaction. The point is really to see it sort of in relation, fundamentally around customer value. This question of experimentation, though, is another, like the cost gravity, is another fundamental thing. And I think we get this wrong. I think that we're just sort of catching up to something that science has been looking at for about a half a century now. Anyone read the book Chaos by James Gleick? It's a fabulous book, and it details a lot of research that was done in the middle of last century on nonlinear dynamical systems, right? So back in the day, maybe like Newton's time, as we're trying to figure out things, the assumption generally was that there were two types of things. There was either disorder, something that we had no way to make sense of, or there was order. And order tended to be described mathematically as a system where time could run backwards and forwards. So you could take the system forward in time and reverse t parameter and take it backward in time. Some of the scientists, as they started looking at things like fluid flow, right? The smoke coming off of a cigarette, something like this, they were saying, hey, we can't actually model these systems using that idea that you can just go forward in time and backward in time. And one of the fundamental results out of that is that there are systems that behave chaotically, and they behave in a way that is very sensitive to their initial conditions, right? So wherever the system started, where you think it started, if you start modeling that system, you can end up diverging dramatically from where it was. And this was a MIT professor's experiment. He was modeling the weather, needed to take the system down, had a printout of all the values in the system, brought the system back up, inputted all the values, and it was a deterministic program. He ran it for some amount of time, and it ended up being in a completely different space than the other program. It was deterministic. How did it get to this completely different space? And it was because of the sensitivity to initial conditions. On the paper printout, there were like 3 decimal places. The machine had like 6 or something like that. And that disparity between the actual values and the perceived values resulted in the systems diverging significantly. In this framework, which I believe is pronounced Kinefin, but I could be wrong, it's a Welsh word, David Snowden created this as a sort of way of understanding knowledge systems and organizations. The interesting thing is the words best, good, emergent, and novel have to do with how we interact with these systems. So order, what's order about? I mean, fundamentally it's about this, right? Order is about cause and effect or predictability, right? A system has an order if we can predict it. The real value to us is being able to say, I'm at A and I know I'm going to end up at C. Right? That's the fundamental value. The problem is not all types of order permit that very simple linear predictability. The two on our left, the complex and the chaotic, are very interesting systems. So anyone heard of Conway's Game of Life? Right? An amazingly simple system in terms of configuration, 2x2 grid, these cells, they can have an on or off value, and then there's some simple rules for, as you advance time by 1 tick, whether a cell is on or off, or alive or dead, based on its previous value and the value of the surrounding cells. Out of that very simple system description, we get emergent behaviors. They may cycle, a periodic behavior, poof, go and go off. They may sit there just stable, not changing at all, right? All these different types of behavior. When it comes to predictability, right, it's very hard looking at that grid and its initial placement, right, until you really understand the system, what that behavior is going to be, right? So if we're building software to create value for our customers, and we're dealing with a system that has this sort of complex behavior, one of the fundamental things that we absolutely must have is the ability to experiment at very low cost. And it can get even more complicated than that, right? If we end up in a chaotic system, or a system whose behavior is only stochastically predictable, right? So you have any particular instance of this system's behavior, and it tells you about nothing until you have a statistical sample that you can make some prediction on, right? So thinking, well, we're gonna kind of come back to this, but thinking about that, Michael also wrote a book called The Innovators Hypothesis, where he says that simple, fast, and frugal experiments inspire creativity and capability in a way that better analytics and planning can't. Why is that important? It's important to me because most of the way that we build software is someone says, here's my idea, and then there's some planning, and then there's some execution, and then you deploy it, and then someone interacts with it. And the person that's planning it is probably pretty far removed from the person who's interacting with it. They're probably far removed from the people who are actually building it. Those people are removed from the people who are deploying it, right? So our typical waterfall model, which you can reformulate and and I kid you not, I've had a project manager tell me, oh, Agile waterfall is a thing. Okay, that's interesting. Or you can do Agile by taking a bunch of little waterfall processes and putting them together, right? Kind of go around that loop. But this analytics and planning and all that stuff, as opposed to experimentation, is a really interesting thing to think about. DevOps is a very interesting movement, right? So Jez Humble gave a keynote speech at a chef conference recently, and he's basically making this point as well. He used the word water scrumfall, which is interesting. But the understanding and the perception that ops is not something that you can sort of completely remove from software engineering is significant, but this insight is still very focused and localized sort of there, right? So I want to explore that just a little bit, but I'm going to take a slight detour and talk about one of the ideas that we started with, which was general purpose programming. So we've all sort of heard if you have a hammer, everything looks like a nail, right? But I think there's a more subtle bias, intellectual bias that happens here, that when you think you have a general purpose tool, your problem is a general problem. I might be splitting hairs, but I think it's a little bit different than just thinking things are nails, right? Just sort of misapprehending the nature of the thing, but misapprehending the sort of order or complexity of that thing, right? And this is related to, I think that, us as sort of information workers, building software, thinking about things, we deal with information, and so I think this sort of general purpose thing is related to how we abstract. Now, I'm breaking a rule of presentation here. It's before lunch. I'm showing you food, but I've abstracted it a bit. Anyway, about 30% of you weren't listening to what I was saying anyway, so now about 100% of you are thinking about food, right? So we have some vegetables, and they can be pretty tasty all by themselves. I might not want to eat a whole tomato or 3 carrots or something like that. So we tend to prepare the food, right? So we dice it up, and we have a nice salad, which is sort of this intermediate, like, abstraction in a sense. But you can go all the other way. You can go all the way to the right? You can make puree out of that. And that's not quite as appetizing as a salad, right? And I think this is more than just analogy. Every time I hear, well, everything is an object, this is the idea that comes to my mind. Right? When we look at a book, we don't say, well, everything is a word. It is, but there are paragraph structure and section and chapter structure for a reason, right? So we can take this whole information abstraction thing down to the level of puree, but I think it's important to recognize that there's a midpoint that might be the sweet spot in how much we abstract, right? In a similar way, there might be a sweet spot in how much, how we move down this spectrum to general purpose and then specialized. And then as we specialize, I think what we tend to do is kind of abstract, go down a layer. We end up in some sort of general purpose and go again. I think that those are related. The way that, so this is an example, a great example from this book called Something Really New, talking about innovation. And the point that he makes is that there's function and there's task. And when we confuse those, I think we end up in a difficult space, right? So the function of the faucet is to deliver running water. Right? And if you're innovating on faucets and you think that the function is primary, you end up with what we kind of have right now, right? So I want to take a shower in my room, I turn the dial, I wait for the water to adjust its temperature, and then I turn it some more, no, not quite right. Turn a gallon of water later, right? It's like, okay, that's about the right temperature, right? Because the task that I want to do is I want to take a shower, and taking a shower, I want it set at a comfortable temperature, and I don't need really to spend a gallon of water testing to figure out the comfortable temperature. We have the ability, right, to actually say, set it to whatever, comfortable, right? So when we're innovating and we think about function versus task, we think about the type of order of the system that we have, and we think about customer transformation and collaboration, right? How many of us still have a development arrangement, I want to say, that looks like this, right? So business, product, someone has an idea, over to software engineering. Please estimate that for me. If you can break it down into sprints and iterations and all that, right? Give me a number, what's it going to cost? Build that, kick that over to IT ops. Oh, IT didn't know that was coming. Hang on, let's order some more servers. No, I got this. We got AWS now. I just need my credit card. And then finally in front of the customer. I mean, I'm joking about this, but I see this everywhere. I talk to people everywhere, and we're still building software like this. It's the way we're doing it. What are the risks? What are the costs? And what are the outcomes of building software like this in the digital revolution, where that cost function it's accelerating, right? It's an exponential graph. The rate of change, right? The rate of change itself is changing. And why I think that's interesting is that if you're driving a car and you're accelerating, you have less and less time to make a decision. You have less and less time to steer the car, brake the car, whatever. And the consequences of your actions can be more severe, right? So you're going at 20 miles per hour and someone runs out in front of you, you stop. You can stop within time. You're going 60 or 80 miles per hour, you can't, right? So what's the analogy in where we're making software like this, dealing with a situation that's changing almost underneath us? So we've innovated on that a little bit. I'm really happy that at Innova we are using full stack teams. We have a front end and UX person. We have software engineering and DBA, sort of all at the table. Maybe we have ops. But the interesting thing is, have you ever heard of the term parallel play? I have a 2-year-old daughter. And parallel play is where kids get together and they look like they're playing together, but they're just playing next to each other, right? So how many of our full stack teams are sort of doing parallel play? They sit at the same table, they talk, they go to the same stand-ups or scrums, they participate in the estimation process, they, whatever velocity, blah, blah. But they're just kind of doing their own thing. Oh, got to do some DBA stuff, okay. Done with that yet? Almost done. Where's the communication, the collaboration going on there? Is ops even there? You can do this really well and then throw it over there. Ops, can you please do something with that? What I'm really curious about is what would it require for us to get to something like this? What if analytics didn't come in after you deployed the thing and said, this funnel not making sense. We need a few more probes, right? Or what if marketing wasn't like, yeah, I want these numbers to be a little bit over here. Can you talk to analytics, right? All of these different roles that we have. And again, I'm not talking about pureeing this. I'm not saying that your DBA should be able to do analytics stuff, right? Which is one of the pathologies, I guess I would say, of full stack teams. Well, you're all on the team. You can all do this. You sit next to the guy. Why can't you do this database optimization? Well, I'm not a DBA. Yeah, but it's SQL, right? What about the customer? Does the customer have a fundamental, vital, participatory, collaborative role in your development process? Is the customer literally at the table with you? Is there a customer proxy? The product person is like, I'm sure this should be a drop-down field. Software engineering, IT ops. Again, if we're going to experiment, and we're going to experiment fast enough to innovate in this environment where things are accelerating, why wouldn't we be striving for this sort of cooperative structure? Like, the question I would have is, if there's a reason for the marketing person not to be sitting there with you as you're developing, what is that reason? What's the reason for that barrier? If the product person has so many other things to do, right? It's like, I already gave you some work. Are you done yet? Right? If that product person has so many other things to do that they can't participate in the development, why is that? An even more basic question. From the time that your project kicks off, how long until it's in production? Anybody measure that? It's a really interesting question. So Rails should have it in production in about 10 minutes. Like literally 10 minutes. But never yet have I seen people do this. Yeah, we'll deploy it at the end of this iteration. It's a week iteration. We'll do a demo on Friday, and then we'll deploy it to staging. Why? It doesn't cost you anything to deploy it right to production. It doesn't have to be in the DNS yet. No one can hit it externally. But I don't see us asking these questions. I don't see us questioning, why do we wait a week, 2 weeks, 3 months before we actually put that thing in production? Before we're actually interacting with somebody. Okay. So all those questions, I'm going to give you just a little bit of stuff about Rubinius and what I'm trying to achieve in that context, right? So again, the way I see Rubinius now is a platform for experimenting. And what I want to empower people to be able to do is experiment more cheaply. So one of the first things that I'm going to talk about is the release process. This is very recent. So for a long time, for almost 2 years, while we were trying to get 2.0 done, we didn't do a release. And I tried everything except releasing to engage people, right? So I would do like, here's a nightly build, and here's a, whatever, this sort of tag, and like all this sort of stuff. People just don't use it until you slap a, real version number on it. Like, I can't deal with a git hash to know where I'm at, any of these things. So we went from that to what I strive, right, to get to is about a week or 2 weeks, right, which is still pretty long, right? And part of the problem was that we're using Git, we've been using Git since before GitHub. One of the problems was that there were files in the source code checked into Git that had to be changed in order to do a release. Do any of you have that problem? So finally, it dawned on me that the fundamental thing that was holding back that release process was this idea that we had checked into source code files that had information that didn't need to be there. I can derive everything that I need from a tag, right? And so our release process now is to tag a commit, which means a couple of things. One, every single commit is a potential release, which is what I want. Two, there's no longer any race condition. That contributor over there and me over here, or those two contributors, don't need to actually make changes that could result in array. So I tried to release 2.5.2, I tried to release 2.5. You made it there first. Your code is different than my code. Now I have these other commits. I need to like adjust things. So it's completely gone. There's just a tag. And if you mess up a release, you simply push a delete on that tag, delete the tag, and tag a new commit, because every commit can be a release. And the final thing is I've separated release from what I'm calling the deploy artifact, essentially the tarball that says, here are all the files you need to build the system, right? So a lot of times I see release coupled with deployment, right? And you have to sort of release, and even the way we're doing continuous delivery is kind of like, well, if it works end to end, then it's a release. But I'm more than willing to accept that there are releases for which there are no deployment artifacts, because a release is just a tag, and I can just delete them. And I can leave that number monotonically increasing so people can be happy doing, like, if this is less than that, I really don't care. Ultimately, the artifact is what people use to build. So that's one thing I'm trying to do to accelerate how we can get this system in front of people. The next thing, give a little bit of background. So Rubinius is a fairly typical, these days, system in that it can take some code. There are some number of intermediate steps that produce a thing like a tree or a thing like some instructions, right? So it's pretty straightforward. It's like the JVM. It's like a lot of other systems, right? The interesting thing that I'm working on now is taking those instructions and not necessarily making those an end stage, right? So a typical flow here is you parse the code, you get some sort of tree, you compile that, you get some sort of instructions, you execute the instructions, right? And those instructions are basically only of one type. They're whatever the semantics of the program are, right? So you go to the JVM, it has instructions for like, setting a local, getting a local, pushing something on the stack, adding two numbers, that sort of thing, right? So one of the things that I'm looking at, I'm going to talk about in just a second, is what that instruction set really is. Fundamentally, what I'm trying to do with Rubinius is build a specification of an instruction set that has a few very specific characteristics. The other thing that I'm working on is this idea of disentangling what I think are two fundamental concepts that are typically just stuck together, right? So on the one hand, we have functions, right? And the way that I've been describing this to people is that functions are for data, right? This set, mapping this set to that set, that sort of thing. And objects are for interaction. The interesting thing is that when you add types, people love types these days. Types are the next Agile, maybe. When you add types, you want a total result, right? What you're trying to do with types is you're trying to avoid any ambiguity, right? But when you're dealing with interactions, when you're dealing with the coupling between two systems, you want to minimize the surface area. You want to minimize the two sides of that system that have to coincide for it to interact. So in my opinion, types and objects are fundamentally at odds. Sorry, C++, Java, everything else that puts types on objects, right? There's a paper, really good paper that I recommend called Why Objects Are Inevitable. The actual title is The Power of Interoperability, Why Objects Are Inevitable. And he argues that either you have something like objects or you build something like objects because the value of interoperability is so high. Because we have systems where we have to have one part of the system with a different velocity or a different, some sort of different characteristic of how it changes than this other part of the system. So one of the things that I'm introducing in Rubinius is support for data. Instead of your typical object-oriented object, which has instance variables and a class and stuff like that, there's just simple data and there are objects. So I can support the idea of functions and object-oriented interaction. And where that's especially important, I think, and critical to being able to experiment more quickly, is in something like parsing HTTP or JSON, right? In a language like Ruby, you pay a tremendous cost because bytes and numbers and everything else are essentially objects, right? They're sort of made only possible to interact as objects. And I don't need to interoperate with bytes, right? There's 8 bits in them, apply some encoding, so I have some interpretation of them, but they're just bytes. And when I'm parsing bytes out for HTTP or JSON, or I'm trying to template into XML or JSON or something like that, I need zero interoperability. I know exactly what those bytes need to do. So I need to be able to put in the center of my program a well-typed functional subset that can deal with those bytes, while the outer part, or the part that has to interact with something else, interoperate with something else, can not be subject to the strictures of that type system. So that's one of the biggest things that I'm working on in Rubinius right now. And the other is, back to the instruction set, DTrace. Anyone heard of DTrace? DTrace is a fantastic program. It's had a couple really interesting design goals. One, it had to be absolutely safe, because they wanted to use it in production, and if you took down production, they weren't going to allow it, right? The second is it needed to be performant enough to be available, and it needed to be efficient, right? It wasn't just like, turn on the fire hose, gulp down all this stuff, try to analyze it later. It needed to have a way for you to limit what you're collecting, right? So the way they approached that is they built a VM directly into kernel, right? So it runs in, protected, or in the kernel mode, right? So it could take down your entire system. And the way they did that is they made it a non-Turing complete language. So you can do pointer chasing and computations and collect some data and all these sort of things in a way that could never be subject to not halting, right? Which is fascinating. So pulling from that example, one of the things that I've looked at is segmenting the bytecode instruction set, not exactly bytes, but the opcodes, the instruction set, into at least 3. There's actually 5 different sections, but these 3 are critical. The semantics, what the program actually computes. The correctness, is it doing what I expect it to do right now under these conditions? And analytics, how is it doing? Or instrumentation, right? We tend to put all these things together. There's a great series of papers by a group who started out building a bytecode instrumentation DSL for Java. And their second paper was about how it did all kinds of crazy things, like resulted in lock inversion, deadlocking the JVM hotspot, segfaulting it, all this other stuff. And then the final one, which was sort of how to deal with some of those things. So the way that I'm dealing with it is I want to segment the instruction set so that I can actually inject assertion bytecode to say that under these conditions, what I'm computing is expected. So if you saw the talk about contracts, a similar idea, and instrumentation. So I can also inject, and again, at runtime, potentially, without ever having to be concerned about mutating the semantics of the program because it can't participate, right? So if it's correct, you should be allowed to do it, right? So if you have to, we're a very highly regulated industry, we have to have SOX, compliance, that sort of thing. The separation of responsibilities, not changing code in production. If I can provide a system where we can experiment with, while being assured that we're not changing the actual semantics of the code in production, and I can do that on the granularity of a single compiled code object, a single method or a function, right? That sort of thing. I think that that's going to provide a very powerful system for doing experimentation. And one of the last things I'm working on, there's an editor called Atom that GitHub is sponsoring. And using that platform as a distribution mechanism, right? So I have built a plugin to Atom, right, which fetches a binary of Rubinius, puts it into a place that doesn't conflict with your Ruby, whatever system version or anything else in your system, allows you to run it, experiment with it, and even potentially more interestingly, communicate back and forth between the editor, whose task it is to edit code, and the console, whose task it is to do things like running command line programs. And I don't want to mash those together. I want them to be able to be their own thing. So if you take one thing away from this talk, I think the Kinefin framework is very important, but I think the most fundamental thing is an understanding of this cost gravity and how it impacts the things that we do, how it impacts the decisions we're making, where we are on that graph, what happens at those inflection points, right? Why do we have general purpose things? How do we specialize? How do we innovate? How do we experiment? All of those questions, to me, it really is fundamentally this, right? And I have probably a few minutes if anyone has a question, and I will be around as well. Come on, someone must have a question. I said a lot of controversial things. If you agreed with everything that I said, I would love to meet your company.
Can you elaborate a little bit on what you see systems or the digital revolution, as you put it, turning into once we pass out of the general purpose stage? I mean, this is the new reality, deal with it, but what does that entail? Can you elaborate on what you want us to take away from that specifically?
Sure, that's a great question. So one thing that I know very well is that I can't predict the future. However, I think that looking at what we're doing and the history of what we're doing, looking at something like 3D printing, or the fact that we all carry, I haven't had a phone in over a decade, right? I have a computer in my pocket that allows me to communicate by, voice, text, or video, thousands of miles away, right? So the universal reality of information processing exists. I have a fairly general purpose computer. It's got a specialized motion chip, it's got a specialized GPU, it's got a CPU that is, somewhat general and these sort of things. But there's tons of places that we see around us specialization occurring. FPGAs, right? Why would you use an FPGA? Right? Because you can do some circuitry that is more performant than this general load, decode, right, sort of thing, right? So why aren't all computers FPGAs? Because it still costs too much, right? They can't make them as efficient for some things, right? So I think what we're going to see, and I think if you want to look at where we're going, and I highly recommend that we consider this, look at the places where it looks like we're using a general purpose tool and just ask what would that look like if it was more specialized? What did it look like when it was custom? What does it look like now? And what would it look like when it's more specialized? And if you're dealing with information and you're abstracting it, ask yourself, are you at the level of salad? Are you at the level of vegetables? Are you at the level of puree? If you're at the level of puree, I think you've gone too far. Does that help answer your question? Anyone else? Yes.
Sure.
Achievement unlocked. We all know who this man is, right?
So I wonder, so you're focusing on these curves, basically, and I'm wondering if those curves aren't really part of a circle that you're just too close to and such. And in particular, your curve that goes from impossible to general purpose to specialized, well, often the way we get to general purpose is we start with specialized, then from that we generalize to a general solution that addresses a broader set of problems than that specialized. And then we find again, well, now there are new things we're doing with this and we can build optimized, specialized solutions, and we build a few of those, and then we start the circle of reincarnation again.
Yes.
And my sense, in technology in general, and certainly in our industry, we have many more of these circles of reincarnation than we have just these generally infinitely trailing, exponential curves.
So that's a fantastic question. It's a very good point. So one of the things that I talk about a lot is how what we perceive as linear is really a circle, right? So that is definitely something to recognize. I think that there are fundamental differences between custom and specialized, and I don't know all of those yet. This is a fairly new idea. I was just looking at this cost thing and being like, I know we build custom things, right? So a custom built, like RepRap or something like that, versus the one that you've set up to produce some set of things, right? So building a custom system at IBM when we were just sort of figuring out this digital computer thing versus the very specialized devices like a GPU or accelerometer or a thing. I think that there are differences, but I would agree that what we tend to do is as the cost gets low enough and we start to specialize, we leverage that, right? There is real value in that specialization to explore another domain or another level of that, and we start building some custom stuff. We learn sort of what that looks like. We sort of generalize that. And then taking advantage of the significant leverage, right? So a few companies having computers to millions of people having computers is radically different. And millions of people having computers to a few people having cell phones, to millions of people having amazingly powerful computers in their pocket, another big difference, right? So that's, I would agree that there's some sort of cycle going on here, but I think that what we're seeing on that cost graph, and again, this is not a global thing, right? That cost gravity graph is very specific to what you're looking at, right? I can't, you know, it's like a flying car for me right now is an impossibility, right? But an amazing computer in my pocket is not just possible, but it's something that I can almost pay for maybe with a couple months, you know, extra salary or something like that, right? So radically different things. Does that help answer your question? Anyone else? Please, I love questions. Ask me questions. Especially Agile. Did I get Agile wrong? Have I misunderstood Agile?
So if you were to coin
Yes.
a name to this, I don't know if you want to call it a philosophy or a thought or whatever, what would you call it? Like, the Agile.
The custom general specialized or what?
Yeah, like how you went through so many things and you arrived at this whole thing because you have a problem,
right.
or you're solving the Rubinius thing. I want to be able to go back to my CEO and say, you got to listen to this on YouTube. So, like I want to say, hey, this is something cool. Yeah. Like we need to be thinking globally from the top down and the bottom up this way, because if not, somewhere in the middle, we're going to lose to our competitors who are going to be more disruptive than us.
So as the saying goes, there are 3 hard problems in computer science, right? Naming things and off by 1 errors. I don't have a name for it right now. If I were to call it anything, I would focus on cost and change, right? It is the rate of change that's accelerating, driven by the falling cost, and those two together are forcing us to make fundamental changes. Like, it is no joke. If you look at a project cost and that graph and you see that thing going, there's a point where that cost exceeds what the organization can support, and you will go out of business, right? And the time to that point, from where you start to deviate from the cost graph and the point where you're going to go out of business, pretty sure it's accelerating, right? If it's not accelerating, it would either be constant or slowing down. Is there any possible mechanism that would make it slow down? There's not. I don't think that's possible physically, right? So either it's staying constant, right? You have a constant interval between starting to deviate from cost and going out of business, or it's accelerating, which means your time to make decisions is less, the impact of your decisions is potentially greater. So, awareness of change and cost, I think, are fundamental. Sorry, I don't have a name for you. If anyone has a name, I'm happy to, attribute you. Any other questions? We have to break for lunch. Okay. Thank you very much. I'll be around.